Good morning, ladies and gentlemen. Today we are into the 23rd lecture of this course, and we are going through the research design. We have discussed various aspects of research design in the one of the previous classes. We discussed the informal experimental designs. Today we are going to discuss the formal experimental designs. We have already discussed what are the ingredients of experimental designs. So, the formal experimental designs are those designs who offer more control and a precise statistical procedure for analysis. We had observed in the informal experiment designs that control was there, no doubt, but the statistical procedure that was adopted was very simple. It was not sophisticated. Here, there is more control and also the statistical procedures are sophisticated for the analysis. Not very sophisticated, it is very easy. The formal experimental designs are the completely randomized design, that is CR design, the randomized block design, that is RB design, the Latin square design, and the factorial designs. In this very short period of time, we shall not be able to discuss all these in the detail. However, we shall be trying to do as much as we can. So, let us discuss a few of them. Number one, the completely randomized design. It involves two principles, which is the principle of replication and the principle of randomization. It is the most simple design which is possible. Its procedure is also simple. The essential characteristic of the design is that subjects are randomly assigned to experimental treatments. So, for example, if we have 10 subjects and we wish to test 5 under treatment A and 5 under treatment B, the randomization process gives every possible group of 5 subjects selected from a set of 10 an equal opportunity of being assigned to treatment A and treatment B. That is what is the special about CR design. We had 10 subjects and we wanted to test it 5 under treatment A and 5 under treatment B. So, the randomization process gives every possible group of 5 subjects selected from a set of 10, an equal opportunity of being assigned either to treatment A or treatment B. The most frequent statistical analysis which is used in such kind of design, that is completely randomized design, is the analysis of variance, one-way analysis of variance, or one-way ANOVA, which is the most appropriate technique to analyze such a design. Then this CR design or completely randomized design is further subclassified into, say, two group simple randomized experimental design and random replications design. Let us discuss them. In the two group simple randomized design, first of all, the population is defined, and then from the population, a sample is selected randomly. So, of course, for any research, the population has to be defined. What are the members or what are the items which are going to be under study for the problem the researcher is pursuing. So, in this two group simple randomized experimental design, the first step is to in fact define the population, and then from the population select a random sample. There are many ways to select the sample random, make a random sample. The researcher has to adopt any of them according to the problem that he has or she has at hand. It has to be, however, it has to be logical. Why one is adopting a particular sample design has also to be satisfied logically. Further, the items after being selected randomly from the population are randomly assigned to the experimental and control groups. So, we selected a sample. From this sample, again, all those members or items which have been selected in the sample, they would be randomly assigned to the experimental and control groups. We have made experimental group, we have made control group. So, this is not the decision of the researcher, but it is the random allotment of the members of the sample or items, whether in the experimental or in the control group. So, this design yields two groups as representatives of the population. We have a diagram. This diagram is depicted here. There is population which has been defined. A sample has been randomly selected. Now, from this sample, the members or items of the sample have been randomly assigned to experimental group and control group. Any of them can go to any of the groups, and that takes care of many things. Then treatment A is given to experimental group and treatment B is given to the control group. These are independent variables, and then the difference is studied. So, as in this design, The elements constituting the sample are randomly drawn from the same population and randomly assigned to the experimental and control groups. And hence, it becomes possible to draw conclusions on the basis of samples applicable for the population. The two groups, experimental and control groups of such a design, are given different treatments of the independent variables. We have observed this in the diagram. The design of the experiment is commonly used in research studies concerning behavioral sciences. So, it is very good for the social sciences also. We will now discuss one example. The study of two groups of students selected randomly and assigned randomly. So, we have to study the two different kind of treatments, that is in impact of independent variables on the two group of students. So, the population was defined, then the sample was randomly drawn, and then after randomly drawing the sample, the two groups of were made on the random basis. The members of the sample or the items were randomly assigned to the experimental group and to the control group. And here two different kind of treatments, that is the usual training and the specialized training, are given to these two groups. So, and these are, we made the two groups, that is the experimental group and the control group on the random basis. Now, these two different treatments, that is independent variables, would be given as treatment, that is the usual training and the specialized training, to these two groups. So, the usual training is given to the control group and the specialized training is given to the experimental group. Of course, both have been selected and made randomly. The researcher hypothesizes that he has set up a hypothesis which envisages greater gains for the group receiving a specialized training. So, to determine this, the researcher tests each group before and after the training. And then the researcher compares the amount of gain of the two groups to accept or reject the hypothesis. This has been the illustration of two group randomized design. We can extend this example to various other aspects of life, whether it is medicine. Somebody claims that he or she has in fact found a medicine which is very effective for the diabetes. Then again, what we are going to do? We are going to define the population, then make a sample on the random basis, and then we have to make the experimental group and the control group. And this allotment of sample elements or member of the sample who are patients now or items is done on the purely random basis, because in which any of the members of elements of the sample can have equal opportunity to be assigned in either of the two groups. Now, the researcher hypothesizes greater benefits, greater gains for the group who receives the new medicine. So, there is a group, experimental group, who would be administered the new medicine, whereas there is a group which is control group who would be administered the normal medicine. And this way the researcher hypothesizes that there is greater benefit or greater gains or more cure for the group receiving the new medicine. So, to determine this, the researcher has to test each group before and after the training. So, and then researcher compares the amount of gain or the amount of, say, the lowering of the glycoindex for the patients of the two groups to accept or reject the hypothesis. So, on the basis of this, the medicine will be tested for its efficacy, for its benefit, for its implications for the cure of the patients. This was the illustration of the two group randomized design. However, this does not control the differential effects of the extraneous independent variable. That is the limitation of this two group simple randomized experimental designs. So, there is an improvement over it, and we have the random replications design, which you are getting in the diagram. Here, the limitations of the two group randomized design is usually eliminated within the random replications design. Here, by replication, that impact of the extraneous variables, they are tried to be removed. So, in the example, in the previous design, we did not consider the teacher differences on the dependent variables, because whether it is a normal group or it is experimental group, the control group getting the normal treatment and the experimental group getting the special treatment, but where a special coaching or special kind of thing. So, the teacher differences were ignored. That is, the extraneous variable was not controlled. It is the same kind of thing, but we are observing here that there is replication of the design in this design. So, by introducing the replication that we are observing here, the design has tried to in fact minimize the impact of extraneous variable, that is the difference in the quality of teachers in case of example in our previous design. Then we proceed to the randomized block design. It is an improvement over the CR design. In the randomized block design, the principle of local control is applied along with the other two principle of experimental designs, that is the replication and the randomization. So, here we are observing the application of all these three principles of the experimental design. In the RB design, subjects are divided into groups known as blocks, such that within each group the subjects are relatively homogeneous in respect to some selected variable. The design is explained in the diagram and with the help of an example. Then we proceed to discuss the Latin square design. This is an experimental design very frequently used in agriculture sector, and as we have already discussed previously also, that many of those designs which were earlier used in the pure sciences, they are being increasingly used in the behavioral or social sciences. So, in this Latin square design, the experiment is made through the effects of 5 different varieties of fertilizers on the yield of certain crop, say wheat. So, in this, the researcher has to study the impact of 5 different varieties of fertilizers on the yield of a certain crop, say wheat or rice. In such a case, the varying fertility of the soil in different blocks in which the experiment has to be performed has to be taken into consideration. So, we are studying the impact of fertilizers, but there are other extraneous factors which affect the productivity. These may be the land quality, that is different or varying fertility of the soil. It may be the quality of seeds. So, these all have to be taken care of. Otherwise, if it is not taken care of, the results obtained may not be very dependable, because the output happens to be the effect of not only fertilizers, but also the effect of fertility of soil and the quality of the seed. So, the impact of this extraneous variable has to be removed or minimized in this design. So, to overcome such difficulties, the Latin square design is used. When there are two major extraneous factors such as varying soil fertility and the varying quality of seed. So, we have here two extraneous factors, and these two major extraneous factors will be taken care of by the Latin square design. In this design, each fertilizer appears 5 times, but is only once in each row and each column of the matrix of the design. So, in other words, the treatments in Latin square design are also allocated among the plots so that no treatment occurs more than once in one row or any column. That is the beauty of this design. The two blocking factors, that is extraneous variables, are also represented through rows and columns, one through row and another through column. The following diagram gives the form of such a design in respect of, say, 5 type of fertilizers with A, B, C, D and E, and the two blocking factors or the extraneous variables, that is the differences in the quality of seed and the difference in the soil fertility of the lands. So, this is the design which is before you. The above diagram showed that in a Latin square design, the field is divided into as many parts or blocks as there are varieties of fertilizers, and then each block is further divided into as many parts as there are variety of fertilizers, in such a way that each of the fertilizer variety is used in each of the block, whether column wise or row wise, only once. The analysis of the Latin square design is very similar to the two-way analysis of variance technique. The merit of this experimental design is that it enables differences in fertility gradients in the field to be eliminated in comparison to the effects of different varieties of fertilizers on the yield of the crop. Not only that, it does also eliminate the differences in the quality of seeds on the crop. So, a Latin square design is very effective when we are studying a design with two extraneous variables and 5 treatments that we have observed here. So, in the diagram, we have the fertility level or the difference in fertility, and in the row and in the column we have the difference in the seeds, and the fertilizers are A, B, C, D, E. In the 5 plots which were further divided into 5 blocks in each plot, and then we are observing in the diagram that no treatment is repeated either in the row or in the column. We can check it very minutely, and this way the hypothesis is studied for the varying impact of fertilizers of the 5 types on the productivity. By the Latin square design neutralizes or controls the difference in the quality of seeds and difference in the fertility level. So this was the 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 Latin square design. I am sure it is clear, and the merit of this experimental design is that it is successful in removing or neutralizing the impact of the extraneous variable, in this case the fertility of the land and the quality of seed. Then we have the factorial designs. The factorial designs are used in experiments where the effects of varying more than one factor are to be determined, and these are very important in social science studies, especially important in several economic and social phenomena, usually a large number of factors affect a problem. So we should know about we knew about the factorial designs, and that these are very frequently used in the social sciences. The factorial designs are of 2 types. One is the simple factorial design and the other is the complex factorial designs. So these we shall be discussing in detail in the advanced course, which would be most probably launched also, where we can do the exercise of implementation of the factorial designs. With this, I am sure I have been able to make clear the formal experimental designs. Thank you very much.